Okay. We are talking about absolute value functions. The absolute value graph is the V-shaped graph. And today we're going to shift this V-shaped graph left and right or up and down. I'm going to talk to you about making it skinny, skinny, or fat, 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 wide. And all of these things are called transformations. So, absolute value functions, let's go down to here. The vertex form of an absolute value function is written as, so this is what we've seen before with other equations. F of x, or y, equals, all right, a absolute value x minus h plus k. So my h means that I go left or right. And remember how it's the opposite sign? The k is the number all by itself at the end. The k will tell me if I move up or down. HK is my vertex. H comma K is my vertex. And let's talk about what each thing is. If A is 2 or 3 or 4, you know how A is that number right after the equal sign? Then that is a stretch. I'm stretching the graph, and that means I'm making it skinnier. Here's how I write it. A is greater than 1. If A is a fraction smaller than 1, my graph is, and the word is compression, compressed, like pushed down, pushed out. Sorry, I have to write the word compression. This sentence doesn't make sense. My graph is compression. My graph is a compression. That means that it's fatter. Fraction fatter, F fraction fatter. And we've talked about fraction fatter before. So, here's what we're going to do. We're going to identify these transformations up above. I have equations, and maybe there's an A in front. Or maybe there's a number inside the absolute value bracket. That'd be the H, left or right. Or maybe there's a number after the absolute value bracket. That'd be my K. That tells me up or down. So I'm going to identify what's happening because, as you may or may not remember, there's something called the parent function. And the parent function is this. F of x equals the absolute value of x. And the parent function, why is this crooked? The parent function has a table of values that's this. Absolute value of negative 2 is 2. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. And what does that look like? Oh, I'm glad you asked, students. I know, right? Don't you really, really care? It's a V shape. It's a V shaped. That's what absolute value looks like. Refresher. Reminder. Okay. Let's talk about what's happening. Oh, what is the parent function of absolute value? Okay. F of x equals the absolute value of x. Mr. Bustos. Mr. Bustos. Hi. Oh, Burgos? Sorry. Okay, and you know what? He sits there, David sits there, fourth period, like in that same seat, and they get you two confused all the time. Okay, here we go. If I just have a -5 inside, what's happening to the parent function? When I put a -5 inside, it is positive. What direction do I move? Right. 5 to the right. 5 right. Mr. Link, will you switch with Luis and he can sit in your chair? And you can even sit in that one that Brandon usually sits in. It's about to get a lot quieter. Go ahead, please. Switch seats. Luis, go ahead. He needs to sit over there. No, not in Derek's seat, alone. And this is all on video. Thanks for... All right. B, what's happening to the +9? Up 9. Okay. C, ooh, negative. I haven't talked about that. Let me go down to the bottom and talk about it. If A is negative, the graph flips downward. If the A is negative, it means it's in the opposite direction. It'd be like this. Downward V shape. And that's going to be, I say, reflect over the x-axis. That's what's happening. The graph is going downward over the x-axis. It used to be on top, and I flipped it down. Reflected it over the x-axis. Okay, back to C. What's this negative mean? I just said it. Reflects over the x-axis. Reflect over the x-axis. All right, D. There's a 3. Remember we talked about what happens if there's a number in front. That's down below. There's a 3 in front, and then there's a -2. What's that mean? I'll go by tables. Table 4, you're going to do D. Table 5, you're going to do E. And table 6, you're going to do F. All right. Table 4. Let's start easy. What does the -2 do, ladies? Good. 2 down. And then the A is a number. 2, 3, or 4 right here. So what's going to happen to it? And I'm going to use the word stretch because that's the mathematical term. But yes, it does get skinnier. It gets more narrow, close to the y-axis. Table 5, your E. What happens to the +6? What does that do? Oh, that would be if it were a +6 at the end. But 6 inside. Look at the screen. See my pencil? And it's opposite sign. Good job. You're next. Okay, so I'm going to go left 6. And then what does the 1/4 do? 1/4 down here. If A is a fraction. What does that mean? The 1/4. I'm asking table 5. What does a fraction do? If it's less than 1 fraction. Yes, it's called a compression. It gets fatter. Good. F, table 6. You've got a +7 inside and a -2. And a negative sign. There's 3 of you, and there's 3 things. So this is perfect.
Down 2.
Go first. All right, thank you, Jared. You are done volunteering. Down 2. Christian, what does the 7 do? It doesn't matter. I'll take any of you. Either. Left 7. Good job. And then the last, Christian, what does the negative do? Okay, well, we have a negative. Look, I put it down here. Yeah, so this means this graph is going to be reflected over the x-axis. So I can describe the transformation. Now I'm going to actually graph the transformation. And I have some shortcuts for you. I want to let you know that the A is also called the slope. It's how my graph moves, how my line tilts. So let's turn the page. I'm only going to do 1, 2, 3, and 4. I'm not doing 5 and 6 on notes. Okay. So we have to draw our parent function. Let's make our parent function table of values again. That's going to be -2, 2. -1, 1. Ali, you okay? 0, 0. You have a question? Oh. 1, 1, 2, 2. I'm going to graph that. I want you to graph your parent function every single graph. I'll do mine in pencil. It's a V-shaped. Super simple. Okay, but now I need to go identify my vertex. My vertex is +2, -4. So I'm going to write that where it says vertex. It's this number here, opposite sign of 2, and then -4. 2 to the right, 4 down. I'm literally going to move my V-shaped absolute value 2 to the right and 4 down. So I'm going to go for my vertex. So start at the vertex. Start at vertex at 0, 0. Move 2 to the right and 4 down. 2 to the right and 4 down. And make your new vertex at 2, -4. My shape is going to stay the same because A is 1. A equals 1, so I'm going to do this. Let me show you how this works. Look at the board. I started my vertex. I go 1 in either direction and 1 up. So that's going to look like this. 1 in either direction and 1 up. And I make dots. 1 in either direction and go up 1. Over 1, up 1, both directions. Then I go from my vertex 2 in either direction and 2 up. 2 in either direction and 2 up. And remember how A was 1? That's my slope, remember? That's 1 over 1. So I could just go up 1 over 1, up 1 over 1, and keep making dots. And I have to go the other direction. Start from your vertex. Up 1, left 1, up 1, left 1. My slope is 1 over 1. So I just go in both directions, up 1 over 1, and keep doing that. Rise over run, and I could continue forever and ever and ever. left, up, left, up, left, up, left. What's my domain? From left to right, where does my graph appear? It goes forever purple, forever left, negative infinity, forever right, positive infinity. All real numbers. I do negative infinity, comma, positive infinity. Range. That's low to high. Do you remember? Low, comma, high. Start low. Nope, 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 nope. Oh, purple begins here. What's this? What's this line? -4. Oh, is it bracket or is it parentheses? Is it included or is it open circle, closed circle? Closed circle means bracket. Oh. -4, comma. And then it goes up, 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 up. Both directions, infinity. Up, 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 up. Parentheses always is attached to the infinity. All right, axis of symmetry. That's going to be the line that's down the middle. My line is, I'll do it in red. My graph is symmetrical about that line. It's the x value of the vertex. I say x equals 2. That's the equation of the axis of symmetry. Okay. Number 2, my slope is 3/1. So from my vertex, I'm going to rise 3 and run 1. This 5 means what? Someone from table 7, not you. What does this 5 mean?
Left 5.
Left 5. My vertex is -5, 0. So draw your parent function, basic, original, OG. I know, it's the OG right here. Yup. And I need to shift this whole thing 5 to the left. 1, 2, 3, 4, 5. However, I need to do my slope. So I need to rise 3 and run 1 in both directions. I need to make a V shape from my vertex that rises 3, 1, 2, 3, and over 1. And then 1, 2, 3, and left 1. Because my slope was 3. Rise 3, run 1, and then rise 3, and go left 1. And I could do it again. 3 more up. 1, 2, 3, right 1. From the other point, 1, 2, 3, left 1. And make a V shape. What's my domain? What's my range? Write it down. Tell me, what's my domain? Yeah, negative infinity, all real numbers. But my range, however, is not all real numbers. Only straight lines have a range of all real numbers. So, negative, nope. Oh, at 0 it starts, bracket 0. And then up, forever up. Bracket 0, comma, infinity, parentheses. Axis of symmetry. What is it? X equals -5. It's the X value of my vertex. Does this seem easy?
Yes, ma'am.
I'm teaching you all the shortcuts because I do not think that you want to make a table of values. Do you want to make a table of values? No. So let's make it easy. And that's my job, to make math easy for you. You're welcome. Very refined. Very kind. I know. So my vertex is -1, -2. HK, right? HK. I'm on number 3. Did I say that? Let's do number 3. And my slope is 2/1. So first I need to draw my parent function, and then I need to draw my new one. 1 left, 2 down. First I'm going to draw my parent function. Step 1. Always, always map out your parent function. Step 2. Now, 1 to the left and 2 down. Change my vertex. -1, -2. My slope is 2/1. Rise 2 and then over 1 in both directions from my new vertex. Start at your new vertex because this is the line that is transformed. Transformation, transformed. Rise 2, 1 to the left. Rise 2, 1 to the right. Do it again. Up 2, 1 to the right. Up 2, 1 to the left. This 2 made it skinnier. Number 4 has a -1 slope. I'm going to have to, remember this is facing downward. And it's 6 to the what? Right or left?
Right.
6 to the right. Plot your parent function. Am I going too fast? Okay, I'll slow down. Okay. Shift my whole graph 6 to the left, but it's going downward. Damien, could you close that? Thank you, sir. 6 to the right. 1, 2, 3, 4, 5, 6 is my new vertex. 6, 0. Because there's no K, so it's like a +0. And downward. 1 down, 1 to the one direction. 1 down, 1 the other direction. Keep going. So I've got that. Okay, I'm not doing 5 and 6. Your task is 1 through 8.